Greetings, young geometers. Let's take a look at number 16 from practice 7.5. So looking at this triangle, we've got a triangle that is intersected by a line that's parallel to one of the sides. And let's see, what theorem talks about that? Oh yeah, the side splitter theorem. As far as theorem names go, side splitter theorem, I think, hit the jackpot. It's a pretty cool name for a theorem. And basically, here's what the side splitter theorem says. If you have a parallel line intersecting your triangle, that line's parallel to one of the sides, it divides these two sides proportionally, which means, just to simplify the notation a little bit, I'm going to call this the length of XR. I'm going to call that A. I'm going to call this length B. I'm going to call this length C, and then the length of this segment D. And just to simplify the notation a little bit, the theorem says that the ratio of A to B is equal to the ratio of C to D. So, if I use that on this here triangle, I can call, let's say, this will be A over B, so I'll just do x minus 1 over x minus 2 is equal to, and I did the top part, or I call this the top, but it's closest to this angle. So closest to this angle on top, so then closest to this angle on top. So 3x over x plus 4. And now I'll cross multiply. So that gives me x minus 1 times x plus 4 is equal to 3x times x minus 2. Now if you set up your proportion a different way, that's fine. Once you cross multiply, you should get the same values here. So when I multiply these two binomials, I'm going to get x squared plus 4x minus x, so that's going to be, here I'll just write out the step, plus 4x, so that's x squared plus 4x minus x, and then minus 4, equals 3x squared minus 6x. These are like terms, so we got x squared plus 3x minus 4 equals 3x squared minus 6x. And now you got to remember, well, you've had to remember for a little while, but you got to remember back to algebra and figure out how to solve a quadratic equation. We've got x squareds here, so what we're going to do is we're going to get it equal to 0. So we're going to get rid of all the stuff off of one side. And I got 3 x squareds over here on the right and only 1 over on the left, so I'm going to get rid of them off the left. So if I subtract x squared, that'll get rid of that. So if I need to subtract it from both sides of the equation, then I'll subtract 3x from both sides of the equation. And then I got a minus 4, so I'm going to add 4 to both sides of the equation. And so x squared minus x squared is 0, 3x minus 3x is 0, negative 4 plus 4 is 0. So I get 0 equals 3x squared minus x squared is 2x squared. Negative 6x minus 3x is negative 9x, and then plus 4. And then there are different methods of solving quadratic equations. You might remember that one of the easier ways was to check to see if it factors. So I'm going to check to see if it factors, and so the method I use is the big X method, where I do a times c, the coefficient of x squared times the constant coefficient, on the top, so 2 times 4 is 8, and then the b, the coefficient of x, goes on the bottom, negative 9, and I need to find two numbers that multiply to 8 but add up to negative 9. And this one's a tricky one because we often forget that 8 times 1 is 8. And we also might forget that negative 8 times negative 1 is 8. But when you add negative 8 and negative 1, you get negative 9. But since I started with a 2 as my coefficient of x squared, I'm going to put 2x minus 8 and 2x minus 1 and then see where the 2 divides out. And it looks like it's going to divide out here. So this should factor as 2 divided by 2, or 2x divided by 2 is just x, minus 8 divided by 2 is 4, and then 2x minus 1. Now that should equal 0. And I can double check to make sure I factored that right by doing FOIL. Just multiply it out and see if I get this. X times 2x is 2x squared. The last times the last should give me the last. So negative 4 times negative 1 is positive 4. And then the insides and the outsides should add up to the middle here. So negative 4 times 2x is negative 8x. And then x times negative 1 is negative x. Negative 8x and negative x makes negative 9x. Okay, so why is that cool? Because now I can set each one of these factors equal to 0. So x minus 4 equals 0. Or 2x minus 1 equals 0. And if I add 4 to both sides here, I get x equals 4. And here, if I add 1, I get 2x equals 1. Then divide by 2, and I get x equals 1/2. So I've got two possible x values that this could be here. But which one is it? Is it x equals 4 or x equals 1/2? Well, let's find out. Is it x equals 4 or is it x equals 1/2? How can we find out? Well, we can plug them in and see if they work. So, if I plug in x equals 4, 4 plus 4 is 8. That would make this side 8. 3 times 4 is 12. And then over here, x minus 1, so 4 minus 1 is 3, and then x minus 2, 4 minus 2 is 2. So if these proportions work, then we're good. So does 2 over 3 equal 8 over 12? And the answer is yes, because 8 over 12 reduces. 8 over 12 is 8 is 2 times 4, and 12 is 3 times 4. 4 divided by 4 is 1, so you can see that it reduces to 2/3. So x equals 4 works. What about x equals 1/2? If I plug in 1/2, I'm going to get 1/2 plus 4, which is 4.5. 3 times 1/2 is 1.5. And then, let's see, x minus 2. 1/2 minus 2 is negative 1.5. And 1/2 minus 1 is negative 1/2. Well, is it possible to have a negative length on a triangle? No, it's not. So that means that x equals 1/2 is what we call an extraneous solution. So the only true solution is x equals 4.